Does that mean I start right now?
Ready? 3,
Yeah.
2, 1.
Disclaimer. The rise and fall of financial markets makes nearly daily headlines around the world. As the market traders rally forward and race back again, like children playing tag with tidal foam, ignorantly unconcerned or innocently unaware that seawater didn't always have that oily sheen about it. As the occasional home loan, retirement plan, or sovereign nation gets swept out to sea in the bubbly undertow of austerity and market-correcting poverty, and as another trillion buckets of bailout are thrown at the problem in hopes of heading off a sustainable solution, those on the brink of such solutions must wonder what good may have come if instead of funding the repeated failures of the financial systems, we instead focused on funding the sciences that will fuel the future, that will create engines of prosperity, not mechanisms of austerity, that will power advancements in technology, not slick oceans of people with negative equity. And if there is one phrase that can be used against such deficit thinking, it is "This Week in Science." Coming up next.
Found out that we can't put the...
Hey, Justin.
Good evening or morning, as the time zone may dictate, Kirsten.
Yeah, exactly what you said.
I haven't figured that one out.
Welcome, everybody, to yet another week's episode of This Week in Science. Today, I think we've got a pretty good show ahead. I'm looking at all these stories, and I'm very excited about almost all of them. No,
almost.
All of them. All of them. No, I take it back. It's all of them. I'm excited.
So, I'm going to share with the audience. I got them. We have this place that we post our stories to now between episodes, so that we can sort of have a read on what other stories people are bringing and litter throughout. Because I put mine up at the very last minute today, peppered where all my stories should go. These notes from Kirsten, like, and if Justin happened to find any stories for this week, they would go here. I assure you, I have many stories this week, Kirsten.
Awesome. Bring it. It's going to be good. Okay, so on this week's show, we have lots of science news, just like Justin said, and we're going to get him to talk the entire hour.
I'm ready. I have the biggest story of the year.
You do, and so you get to head off the hour with the big story. But other stories that we have, I brought stories about the end of the world. I've got the end of the world in my computer right now. Morphine potentially in your blood, and an itty-bitty, teeny, tiny thing called life. What do you have?
I've got Neanderthals in my family tree, anthropologists who love global warming, and a potential MonkeyCat discovery.
Ooh, we haven't been visited by the MonkeyCat. Yeah, Allie?
I have devices that can see through walls and some mouse pain.
That sounds awful.
I have a mouse thing, too, if I get it.
All right, so head it up, Justin. We've got a big show ahead.
All right.
An hour to fill here. What's the big story this week?
It is right around here somewhere. And it's just... You know what? I don't think I printed that one. Here it is. Okay, so anybody who's been following the show for a while knows that I've had a take that I've gone off on a few times, but here it is. Researchers working on genetic material from Neanderthals have discovered markers which match those of modern human races. These are modern humans that originated only from the region that humans and Neanderthals were known to overlap in the Middle East. So this is modern, non-African humans that trace some portion of their lineage to the Middle East, which then migrated to Europe and Asia, have share genetic material with Neanderthals. What does this mean? What could that mean, Kirsten?
Birds do it, bees do it, even Neanderthals and humans do it.
That's right, Neanderthals and humans. Getting jiggy. I don't know, what do the kids say, Allie? What do the kids say today? They don't say getting jiggy with it anymore.
I don't know.
You don't know.
Getting down.
Get down. That's good.
That's even before jiggy. So So this is something that no one had previously considered possible, that no one predicted that this would have been discovered at some point, and that nobody thought that once DNA from Neanderthals was more closely examined, that this, of all things, would be the result. Nobody, that is, nobody at all would have considered. But me, this is one of my predictions from a few years ago.
We've been playing with this story for years, like 2006, I think. 4 years ago was when the last genetic evidence came out.
Right, and the thing was, I thought that I got shot down because my assumption was once they decoded more of this Neanderthal DNA, they would find links between us and them in there. That they would find crossbreeding in there because Neanderthals. A lot of people assume Neanderthal was much more primitive than he was. But there are signs that he had tools for hunting, for sewing. They had ceremonial burials where they not only buried the dead, but they would leave different herbs, burnt herbs and stuff like that. They had control of fire. They built shelters. So they were a lot more advanced and more what we consider early humans to have been like than we may have considered. So this made me think for the longest time, if we cohabitated the same region for 30,000 years, the scenario of intermixing was very strong. So they decoded DNA from the Neanderthals previously and said there was no markers of early human in them. Debunked. Aha! Now they went the other direction. And what they've done is they've found a set of markers that are in these European and Asian, Middle Eastern modern humans that could only have come from Neanderthal. So pretty interesting twist to what future anthropologists will be looking for in the ancient past. One of the curious things there, too, is if we did interbreed with Neanderthal, it seems as though the interbreeding stayed with the human side thus far. We haven't found Neanderthal that had clear signs of some human interbreeding with it. But what we think we found is that, or what we found now is modern humans having trace elements of Neanderthal. So going back, we also have to ask a whole lot of other questions, like those Neanderthals that we're using, that had the control of the fire, that had the burnt offerings, that had a lot of those things that we consider to be more advanced features, were those purely Neanderthal technologies, or was this something that was learned from, I mean, it's really going to ask a lot of neat questions.
If there was that intermixing, then if they were that closely aligned for 30,000 years, there's no reason why they couldn't have had maybe a form of communication, like learning each other's language, maybe teaching each other things, who knows? Maybe there was sharing.
Yeah, there was some sharing. There was sharing of DNA going on too. There was some element of sharing happening. And sharing to the point where you can conceive of over 30,000 years, families could have potentially been constructed this way. So then you have to wonder about the dying out of Neanderthals, how completely they actually died out, or if they were just more assimilated. I mean, there's a lot of possibilities. This is going to be a very, very interesting question, because one of the scenarios has been that we either outdid them for resources or directly killed them off. Yeah. And that's why they suddenly disappeared. But if it turns out there is more of an integration, if the modern humans who were leaving Africa were just a larger population, or breed faster, or have longer lives and therefore have more potential to have more offspring, we could have just assimilated but dominated through breeding in a sense, so that they could have been assimilated even, as opposed to becoming extinct in some way. So yeah, these are the important thing is the genes that they found. Because one of the things is we think of the world as having many, many races, and we sort of seem to place them on continents. There's sort of European, Eastern European, Asian, Middle Eastern, and African. Africa actually makes up about a dozen distinct races of mankind, whereas all the others that we're familiar with sort of are an offshoot of one of those races some 100,000 years ago. So Asians, Europeans, Native Americans, Eastern Europeans, Middle Easterners, Indians, they all are from this sort of group that left Africa and then changed by dispersing over and I don't know, interacting with the environment differently or evolving a little bit differently, perhaps. So the genes that they found in the that were of Neanderthal origin are not present in the more pure-blooded African races that didn't leave and didn't mix with the Neanderthals. So this is going to be a really fascinating subject to keep covering in the future. I'm very excited by this.
I think it's really exciting. The story is definitely not over, and the collaboration that happened on this study is really amazing too. Something like 22 different institutions and 56 co-authors were on this paper that was published. And the guy who published the Science article, I think it was back in 2006, that was the definitive word on Neanderthals and humans not having interbred. He's actually saying, oh, hey, look, they did some really great work. Awesome. Right. And very often in science, you see people competing for ideas and they're like, oh, I think this, you think that, you're wrong. And there's suddenly a fight over it. But he's just really excited about the work that's been done and the fact that this is, moved forward using technology that's become available over the past few years. And then additionally, with what you mentioned about the genes being present in one group and not in another, so not present in people from Africa. So there is an alternative hypothesis
people currently
to this.
In Africa, yeah.
Yeah, there's an alternative hypothesis to this that they cannot rule out yet, which means that they're going to have to keep looking to see if they actually can rule it out. But they're saying that there's a substructure, a genetic substructure that they've detected that existed within Africa, and so the signal they think represents possibly, and this is the alternative hypothesis, they think that it could represent an ancient genetic substructure that existed within Africa, so that the ancestral population of present-day non-Africans are more closely related to Neanderthals than the ancestral population of present-day Africans.
Well, yeah, but that's very unlikely. I mean, what they did was they compared this to I think it was West Africa and South Africa, a bunch of different regions of Africa, and checked the DNA code there, and it wasn't present there. The idea that the lineage that was in North Africa was just more closely related to Neanderthal, and that's why those markers are there. When that group, as recently as 100,000 years ago, 28,000 years ago to 60,000 years ago, lived in the same region, that seems like a much more plausible scenario than this one group that happened to re-interact with Neanderthals, not having, or still having that ancient markers of their DNA that was similar to the Neanderthal. But the interesting thing is they haven't found any Neander people yet that have the more modern markers. So
yeah, obviously nobody's been watching Geico commercials. Wasn't it Geico? The caveman.
So this is my favorite story in a while, because it's yet another story that confirms Justin's take on the universe as being unfallible.
Yeah, seriously, we laugh. I laugh often. I go, oh, you have another interesting idea. And then a paper comes out and I'm like, yep, he did have a good idea. Okay. It's good. It's good. Oftentimes your logic is infallible, Justin.
Thank you for 5 years of waiting, an admission that I actually do employ logic on occasion. That's awesome.
You're funny.
Was that a wine glass? Wait, did you just get caught between takes?
I did, sipping a wine glass. I did.
Naughty.
Oh, my goodness. So moving on from Neanderthal genomes, let's just go into the science of pain. It works with my glass of wine. I'm dulling some workday pain. Maybe. No, not at all. But anyway, there's a study out recently that suggests that people might be able to make their own morphine in their bodies.
Mm-hmm.
Mm-hmm.
We got the junk dealer on board.
That's right. Onboard junk dealer. You do not have to go down to the corner store. According to scientists, humans excrete a steady amount of what's called the isoquinoline alkaloid morphine in their urine on a regular basis. And so it originally was unclear whether or not that came from the diet, like poppy seeds in your poppy seed muffin in the morning or on your poppy seed bagel, or whether it was made inside the body. So they're like, hey, let's figure it out. And so they radioactively labeled the precursors to morphine, and they fed it to mice, or they injected it into mice. And then they were able to check out the mouse urine and the mouse blood and say, what's going on in there? And they were, in doing so, able to differentiate what came from dietary sources and what was actually coming from the body, because it was getting incorporated into stuff made by the body and taken up in the blood into the cells, and then mixed about chemical Jenga, and suddenly you have another output. And so this study, for the very first time, shows that these mice have the biosynthetic capability to convert a normal constituent of what's called, let's see if I can say it right, tetrahydropaperoline. Papaverylene. There we go. I said this many times before I got in the air and it didn't work. Tetrahydropapeverylene, or THP. You just say that. That they're able to convert this THP into morphine. And so this is the first time that this kind of analysis has shown any organism aside from poppies actually creating morphine through this particular chemical pathway.
Oh, no.
So basically we had like
people are going to be shooting mouse blood.
I know.
Have you tried it? It's great.
Just mouse blood's so
Damn
great.
it in the mouse.
Oh, this episode is like down on the poor mice. Man.
Wow.
Yeah, so the interesting thing is, morphine, it's thought we have opioids, natural opioids in our bodies to be able to dull pain. The idea being that if you're attacked by a predator and you're feeling pain, that it's a good idea that even a slight increase in these opioids or morphine-like compounds in your blood could actually help you to dull the pain and be able to run away and escape. Ignore the pain long enough to be able to avoid the predator, and then you can deal with yourself. The researcher, Zank, his name is Dr. Meinhard Zank. He's at the Donald Danforth Plant Science Center, and he has said it's possible that scientists could someday induce a person's body to create a natural jolt of morphine that might prove less damaging than injecting the substance into the body, which has many side effects, as we well know. So the research, if it goes forward, potentially we could find chemical ways to induce our bodies to make more morphine if you've got a chronic pain situation, and then you won't have to worry about popping pills or getting injections or going down to your corner drug dealer.
Would that have any in the same effect, though? If you produced it naturally, wouldn't that still have the same sort of problems? If you produced more of it than was natural, would that be solving much?
That's a good point. I don't know that it necessarily would be. I mean, it's the feeling of the dulling of the pain, the feeling that the morphine gives you that is what is addictive. The idea, I think, is that if you're not actually, I don't know if it's, I guess you're creating morphine in your blood. Yeah.
It's creating a reward system,
Yeah, it's a reward
the
system.
reason we have it in our brain is so that we will eat or we will reproduce or we will do these tasks. Because if we didn't have morphine in our brain, if we didn't have this junk deal in our brain, we wouldn't eat. We wouldn't, what was the word? Get down.
Get jiggy with it.
We wouldn't be getting jiggy with Neanderthals. Because we wouldn't know to. We wouldn't have a reward for it. So our brain, there's part of our brain that's actually in control. And what drugs do, what any sort of addictive activity does, is it's sort of like hacking the reward system. It's hacking into the onboard drug dealer and exploiting a system that's there for really fundamental biological processes for a non-sentient being, for just a bundle of nerves and sinewy muscles to know to do things. We're at the point that we know why we eat. We understand what it's for. We can track our nutrition and, eat the right foods, the healthy foods, or eat the convenient foods, or whatever we want to do. But the fact that there's still this system that was built for a very primitive-minded creature, it's fun. Actually, we can play with it and hack into it, and do great things with it, and enjoy things that it wasn't designed to give us pleasure to do.
Yep. I agree. Let's move on to another story. I love this. We can talk about drugs all night. I enjoy it. Talking about drugs gives me pleasure. How does that sound?
Wow.
Allie has a cool story, though, about seeing through walls, right? What's up with that?
Yeah, I do. It's a new device, actually, that some researchers have developed that might lead to basically X-ray vision, except not using X-rays. It's actually using terahertz radiation, which is actually better than X-rays because it can safely pass through materials without harming it, which X-rays does do. It harms it. Basically, the researchers are going to present their device at the conference on lasers and electro-optics, which takes place in San Jose, California this next week. And what they developed is a new way to detect and control terahertz, basically by using optics and material science. This type of radiation, it's made up of electromagnetic waves. And basically, people have been trying to do this for a long time. They've known that terahertz waves would be a good way of possibly being able to see through materials and see what's underneath, basically having X-ray vision. I feel like that's just what people call it now, X-ray vision, but it's not with X-rays. But yeah, basically, they've been trying to do this for a long time because they use both, microwaves and infrared radiation, and so this is right in between it. And so there's been a terahertz gap for a while that they've been trying to fill. Both of those are used in communication already. So now hopefully they can use this because they've developed a new way of manipulating the beams and being able to detect the radiation, which has been the problem. They're using new materials called metamaterials, and these materials are unusual in the way that they interact with light. Basically, they can. They're hoping that they'll be able to use this array of different split ring resonators, which is basically a checkerboard of flexible metamaterial panels that can bend and tilt. And so basically they're going to try to control the electromagnetic properties of the terahertz beam by rotating the panels in different ways. The lead researcher says the idea is that you can manipulate your terahertz beam by reorienting the metamaterial elements as opposed to reorienting your beam. So basically they're trying to control, they found a way of possibly using this beam for communication by manipulating the elements that it's interacting with rather than the beam itself, because they still haven't figured out how to do that. So yeah, they haven't invented any devices yet that can see through walls, but this is a big step in that direction. Basically, the panels could function as pixels on a camera do, they would detect the radiation, and the absorption of the radiation would cause the panels to tilt and move in different ways depending on the intensity of the rays or the radiation hitting them. So basically, eventually this could be used to see through people's clothes or things in a package for a variety of uses.
It's going to be and I'm going to call it X-ray too, just because that's
it's hard not to.
We're talking about. But when you really can get those X-ray goggles, I think it'll start a fitness craze. At least I hope it would. Otherwise, I don't. It could. Never mind.
It's so interesting though, the whole idea of these terahertz waves that they don't interact with things. They're high enough frequency that they don't bump into things and damage them, and that's how they go through stuff. And so the difficulty was finding materials that would actually be able to detect them, be able to work with them, and then give some kind of an image back. And so that the fact that these metamaterials are now, they have properties that are so new and interesting, and the way that they can bend light in the electromagnetic spectrum and respond to it. It's so cool. I think it's such a neat movement forward. And yes, I'm ready for my Superman glasses. Either glasses or like a camera, right? You want something that you can use to take the pictures.
You know what I would I wouldn't bother with pictures, but what I would do, my first step, if I had the first pair and it wasn't well known that these existed, my first step would be the local liquor store.
Why is that?
Lottery tickets. I'd be hitting up the scratchers.
Good. I was just thinking, though, that the first thing
guy only buys winning tickets. How does he do it?
How does it happen? That one of the first things they're going to do is this is definitely going to be used in airports, airport security, or in shipping yards to be able to look inside of
the containers. There's the highest and best use right there. Absolutely. Yeah.
You know it. If anyone just tuned in, you are watching This Week in Science. I'm Dr. Kiki, and we're talking about science. It's true. Did you have another story, Justin, before we go to the break, or do you want to just go to the break?
We can go to the break. It's a good time for it. I got a few more stories left, but we're going to come back for another half hour, so let's get to it.
All right. We're going to a break. See you in just a little bit. Stay tuned. And that was a fake break. Okay, see what stories we have left. I think we can... Oh, we're going to have to drop a story or two. Donk, 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 donk. Was there a robot sound from somebody? Did anyone hear that?
Yeah.
I heard some sort of like a TARDIS taking off in the background or something.
Mm-hmm.
I was reconnecting my headset. Maybe that was it.
Yeah, Justin, that was not the sound. Okay, let's come back from the break and we'll go until I'm gonna watch the clock. Keep an eye on it. Okay.
And we're back with more This Week in Science for a second half hour of the amazing show.
That's right. We have so many more stories. The problem is these stories are interesting and I want to talk about them. So we talk and we don't actually get through all the stories in our lists. Justin, what do you have?
Okay, so what's one of the other big predictions I've made over the years? Besides the Neanderthal, the MonkeyCat.
Oh, MonkeyCat. I was going to go with like the oceanic string space.
Oh, that's already been proven. Well enough anyway.
Okay.
It's conceivable at least. But the
MonkeyCat.
In Kalimantan, formerly, was it Burma? Was that what turned into Kalimantan?
Yeah,
I think it's
so.
Kalimantan. Same place now. They had this remote camera set up in the forest, and they caught some sort of snapshots of a creature that they couldn't really see, except that they think it's carnivorous. They got some night shots, a little whiff of a tail, a long tail, and maybe some whiskers. And I'm pretty sure that this is the first evidence of a hybrid monkey and cat, which is otherwise, as of yet, undiscovered. Either that or it's a very primitive ancestor to the cats that's been stuck on this island for a long time. But there's a newly discovered primate that lived in Africa some 37 million years ago. This is from livescience.com, where I got this. A newly discovered primate that lived in Africa some 37 million years ago is somewhat of a black sheep, evolutionarily speaking. And attacking life sciences, to say that something is evolutionarily speaking a black sheep, it's just, I don't know. There's something wrong with comparing it to a black sheep. But anyway, because they're not really evolutionarily any different than any other sheep, really.
Exactly.
It's pretty, But anyway, that's just me being
literal.
too particular. Yeah. So, but this primate they discovered does not fit into it does not fit into any known family tree, no matter how the scientists look at the evidence. So they have found the primate's unusual teeth, and they are finding that they do not match up with the primate groups that were thought to be around and living at the same time. And all they actually have at this point are teeth, because typically teeth are, because of the enamel and everything, they last longer than any other portion of a fossil. So whether it's primitive man or dinosaurs or this primate, a lot of times in the fossil records, if you're going to get anything at all, it's going to be teeth, maybe part of a jaw, that sort of a thing. So this is coming, this is a quote from Eric Seifert of New York's Stony Brook University. It comes as a bit of a shock to find a primate that defies classification. The 12 fossil teeth, the only remnants the paleontologists have of this primate so far, were found in northern Egypt. The new species is called Nosmips, and a longer word. During the last 30 years or so, major primate groups have been established.
Enigmaticus? Nosmips enigmaticus?
Enigmaticus, because,
it's kind of like enigmatic, I guess. An enigma wrapped in a mystery.
Folded into a taquito. Three major primate groups have been established as being present, but and some of them were monkeys. There was lemur-like primates that were like the early monkeys, and extinct groups, others, but nothing that seems to even be closely related to this new evolutionary oddity that they've discovered. It's not just that they have found one that's different than the others. It means that there's an entire lineage, because for this creature to have evolved in this way, it has to have ancestors, and likely has generations that came after it. So this means that there's an entire branch, a very large branch of primates that is now missing, that is now needs to be discovered, now needs to be found, because it's not just an offshoot. It's not something like humans and Neanderthal people. It's something much bigger than that for this much of a difference. And this is still based only on the teeth. But
teeth are a major characteristic that's used in identifying fossils. I mean, if you can get the genes, if you can get the DNA out of fossilized bones or teeth, that's great. But really, when you're looking at so many mammal species, the teeth tell you so much about where that individual came from. If you take a mammalogy class and you go through the process of looking at the different types of teeth and the way that they look, and different species, and some species have like 2 little bumps here, or some have like 3 little ridges, and it's really intricate, and you'd be amazed at how much information is in your teeth.
Yeah, the one thing they've shied away from, it's not actually in the story anywhere. It's not written here. They make no mention of it, but I'm quite sure the reason that they're so confounded by these early primate teeth is that they're so feline. in their that they're cat-like, because I think this is the first evidence in the fossil record of the mysterious enigmatic monkey cat.
The Kalimantan monkey cat.
The Kalimantan monkey cat ancestor.
I didn't know. It's great. The Kalimantan monkey cat has a whole family tree. It's got a whole lineage. We're missing out.
It's more like a family weed, because it doesn't seem to be on any of the other any of the other trees. It's just sort of growing up
it's
by
like
itself.
That stray hair that kind of grows, someplace on your face where you don't want it. No.
You have a stray hair that's growing someplace on your face where you don't want it, Kirsten? I don't have one of those.
I was thinking about you and your
Fuck that.
Fake hair tonight. I don't know what you're covering up with that.
Yeah.
That mop. All right. The smallest. What was that?
Balding back up into here. So I got this toupee that I don't know if it's.
It does look rather toupee-like tonight. Yeah, I do have to say it's a little bouffant.
Yeah.
Anyway, moving on. The smallest life in the world has been discovered in pretty disgusting acidic mine runoff water. Yay! So, published in the Proceedings of the National Academy of Sciences, a study out of UC Berkeley, researchers have delved into the depths of an abandoned copper mine that's out of, I think it's, where is it? Iron Mountain, I think is where it is. It's in Northern California, around here somewhere. And this mine is just highly acidic. The water has a pH that's similar to battery acid. And they found these little tiny microbes that are living in there. And the little tiny microbes have this whole ecosystem that's going on. And they've sequenced the genes and the DNA of all of the microbes to see who's there, what's going on in this really disgusting acidic mine water. And they found a number of microbes, and they're members of a domain of one-celled creatures called the archaea. And these are the oldest known microorganisms. They were a lineage predating modern bacteria. And a lot of times when they're found as small as this particular species was found, they have to give up abilities, and they actually live as parasites. So a lot of really, really tiny organisms that only have a small number of genes in their DNA, they end up living like viruses or parasites off of other larger celled organisms. But what they found some really interesting looking little bacteria. And one of them occasionally produces a really weird protuberance that's not like any other structure that's seen before in these archaea. And it uses them to penetrate some of the other really tiny microbes. And the researcher, Brett Baker from UC Berkeley's Department of Earth and Planetary Sciences, says other cells in the mine have what looks like a needle that sometimes pokes right into the cells. It is really remarkable and suggests an interaction that has never been described before in nature. Woo, we like this kind of stuff. So the cellular extensions, according to another researcher, Luis Camoli, he says that they're only present when this spike is only present when this interaction with the microbes is seen. So they're thinking that there might be some part of the life cycle that they go through where they have to be parasitic on other microbes, and then they get out of that phase, and then they're not parasitic anymore. They're thinking that maybe they're not obligate parasites. They don't have to do it all the time, just sometimes. And so they grow a big spike and impale other microbes and suck the life out of them. Anyway, so these little tiny microbes, they're about 200 to 400 nanometers in diameter. So they're really nanoorganisms instead of being microorganisms. So unlike microbes, which are micro scale in size, should really be calling them nanoorganisms. And the microbes now, they're calling them ARMAN, ARMAN. And that stands for Archaeal Richmond Mine Acidophilic nanoorganisms. So where they're located and where they live. One of the interesting things about the genomes is they found 3 completely distinct lineages of our man, and they found all of the genomes to be really super tiny, only about 1 million base pairs. And the smallest of the 3, the average gene length is about 774 base pairs. Compare that to humans like us that have 10,000 to 15,000 base pairs, the nucleotides that make up a gene. So they're tiny. The genes even that code for proteins are small. Like everything is minimized, the most efficient that it possibly can be. And so they thought at first that they were going to be just parasites, and then they realized that no, that's not the way it works. And 70 individual specimens that they've taken a look at, 90% are free living, and then it's only about 10% that have this spike impaling needle spine. So the researchers say that our man are among the smallest microbes we know of, if not free living, are at least not permanently obliged to be a parasite or a symbiont. They're really about as large as the largest viruses. So maybe there's something going on here that we need to look at more closely in terms of, viruses versus these little tiny archaea. Like, was there some kind of switch over at some point where viruses decided that they were going to get a membrane to protect them and become what we call bacteria? I don't know. Is that the way it worked? We don't know that. And the genome, that is so compact, but it has the highest, a much higher percentage of unknown genes than any other organism that's ever been sequenced. They found 45% of the genes in this little tiny genome had never been heard of before. So this little tiny creature with not very many genes, not much DNA, lives in a really super crazy acidic environment and has all these unknown genes that nobody's ever seen before. The exciting side of this is going to be looking at what allows them to live in this environment, and how do they actually, how does their metabolism work? How do they survive? How? We don't know.
Awesomosity.
Yeah. Let's run through these last few stories quickly. We're getting into, your story, Justin, sounds like the end of the world, right?
Which end of the world story?
Ice patches melting, receding. Sounds like the end
for
of
a
the world.
silver lining in the global warming gloom and doom cloud.
Oh, yes,
Look no
please.
further than the Arctic Institute of North America and their new favorite thing about global warming: ice patch archaeology. Scientists are currently finding a plethora of ancient hunting tools as warming temperatures melt patches of ice that have been in place for thousands of years. Tom Andrews, archaeologist with the Prince of Wales Northern Heritage Center at Yellowknife and lead researcher on the International Polar Year Ice Patch Study, is amazed at the implements being discovered by researchers. Has a great quote here. "We are just like children opening Christmas presents. I kind of pinch myself," says Andrews. So ice patches.
I peach.
I can't believe all these things we're finding. It's not true. So these are ice patches are basically it's tundra, normally covered by ice all year, frozen up, and for thousands of years this has all been underneath the ice. It's been inaccessible to us unless we're digging around looking for it, and it's been melting in greater and greater areas, and they've been finding a lot of ancient man. I think that's one of the studies was started in the Yukon, where they found a 4,300-year-old dart shaft in a bit of caribou dung, which means they were looking very carefully, because that seems like that would be hard. Like that could be every 5 feet around here, and I'd probably still miss it. So the discoveries, because everything's been frozen, these artifacts are very well preserved. He first became aware of the importance of ice patches when word about the Yukon findings started leaking out, and they began wondering if they had the same phenomenon in other places. They started to buy satellite imagery of a specific area of something called the Mackenzie Mountains and examining ice patches. So that what they're doing is they're looking for areas where they know there was early man or man of 4,000 or 5,000 years ago, what would have been very likely hunting grounds, probably along caribou paths, but areas that have been traditionally covered in ice that are now sort of receding under the global warming. Lo and behold, we found a willow bow. Discovery that led successful application for federal international polar year funds, which have allowed a team of researchers to explore 8 ice patches over the last 4 years. Results, they announce, have been extraordinary. They have found 2,400-year-old spear throwing tools, 1,000-year-old ground squirrel snare, and bows and arrows that dated back 850 years. Others are studying DNA evidence to track the lineage and migration patterns of the caribou themselves. So I'm just glad that I don't live 1,000 years ago and have to try to snare ground squirrels for food.
You could. I mean, there are plenty of ground squirrels in Davis. You could.
Yeah, but you don't have to
snare up a couple for lunch if you wanted.
I don't need to snare them. You just go out by the outskirts of town. You hit the open road, and there's plenty of roads.
Kamikaze squirrels.
Like today, I mean, what I was saying is you don't have to. In the old days, you would have had to snare them yourself. Now they just get hit by cars, and you got plenty to eat.
That's right. Nice roadkill. So there is a silver lining to the end of the world. I'm going to go into the not so silver lining. The frogs are going to die.
Yeah, frogs are always dying. Frogs are such hybrid poodles.
Frogs are dying.
They're so genetically weak. They should just move on.
And well, they might be if climate change has anything to do with it. Researchers looking at things that potentially could be killing off the frogs. There's been this proposed link between the chytrid fungus, Batrachochytrium dendrobatidis, otherwise known as BD, the chytrid fungus. This link has been kind of tenuous. It was based on some correlation of time and space, so temporarily confounding correlation. Damn the confounding correlations. But researchers now have unconfounded the evidence, and they say this in their abstract. They provide temporally unconfounded evidence that global El Nino climatic events drive widespread amphibian losses in a particular genus, the Atelopus genus, via increased regional temperature variability. So temperature variability swings high to low much more often or dramatically, and that can basically get amphibians reduce their immune system's ability to fight off something like the chytrid fungus and leave them defenseless against pathogens. They tested 26 different climate variables, and they found out that there were basically 2 things that accounted for the majority of the variation in the decline in these frogs. So 2 things. One of them, El Nino, accounted for 59% of the decline, and then the epidemic spread of the fungus. And so the 2 of those variables accounted for 83% of the variation in these frogs. So it's pretty clear that as the climate changes, and if it affects these weather patterns like El Nino, if it changes the temperature variability, if it increases the range of temperatures that animals like frogs have to deal with, that they're not ready to deal with, that this could affect biodiversity quite a bit. And then we move on from frogs to humans. Yay! Yeah. Research survey says, thanks to David Eckert for this story, the Earth is probably going to get too hot for humans if we don't curb those carbon emissions. So heat stress is already a leading cause of fatalities from natural phenomena, says Professor Stephen Sherwood of the UNSW Climate Change Research Center and Associate Professor Matthew Huber of Purdue University. And this article, again, is published in the Proceedings of the National Academy of Sciences. And so they looked to see if temperatures went up around the globe. Temperatures go up. What would happen to people's ability to survive in these hotter environments? So, and then we have to look at whether it's a wet environment that gets hot or a dry environment that gets hot. So like a dry desert that gets really hot, it really is not quite as bad as a really humid environment that gets really hot. And so a lot of people think that humans are going to be able to just simply adapt as the temperatures change and that we're going to be fine. But that's not necessarily going to happen. When measured in terms of peak heat stress, including humidity, this turns out to be untrue. So taking humidity into account, here are the numbers. Humans maintain a core body temperature around 37 degrees Celsius, 98.5 degrees Fahrenheit, and a skin temperature is around 35 degrees Celsius. If you sustain your skin temperatures above 35 degrees Celsius, that can increase your core body temperature because your body's having to work to create sweat to like cool yourself off through evaporative cooling and all these different methods that it uses. But eventually your core body temperature is going to start to increase because your body can only do that for so long. So to avoid elevating your temperature, you have to have what's called a wet bulb temperature. So that's like your skin being moist, wet with water on it and having air blown against it. A wet bulb temperature of 34 degrees Celsius or lower. And skin temperatures of 37 to 38 Celsius would pretty much become lethal because your core temperature could raise to about 42 to 43 degrees Celsius. Ouch. So you wouldn't be able to survive really, really high temperatures very long, maybe a matter of hours. And so they looked at an increase of 4 degrees Celsius in wet bulb temperatures around the world. And they found that it would subject half of the world's population to this kind of heat stress. A rise of 7 degrees on the global air temperatures increases temperatures above 35 degrees Celsius. And in some locations, a shift of 11 degrees Celsius would make the most common temperature that anyone has to deal with on the planet around 35 degrees Celsius. That basically this is going to, if things keep going up, it's going to be very difficult for people to handle it. And the idea that we'll just be able to make more air conditioning to deal with it or more swimming pools, I mean, after a while, that's just not the energy that's needed. It's just not going to happen.
Yeah, more likely the requirements of all those air conditioners on the energy system is going to cause enough wars that is going to reduce the population enough to where we'll all be able to move to the nice climates.
Yep.
There'll be a run on real estate at that point. Actually, I think that's really bogus, though. I think that comparative thing about if the temperatures rise, like we would not be able to cope or deal with that. I don't believe that for a moment. I think people would climatize to it much better than is thought. I think that our human body can do this. And I only say this from my own experience, living in some place where it can be 114 degrees during the summer. And then back east, I know the humidity plays a role, but they can have a heat wave that's in the 80s and a lot of people die.
A lot of people die. Mm-hmm.
So
yeah, I mean, deaths from this kind of stuff. I mean, it'll kill
it's
off
the
a lot
difference.
more
I think it's the difference that you experience more so than the climate itself. For instance, is when I was in Greenland for like 3 weeks, and by the end of it, I was like wearing a t-shirt and shorts, even though it never got above 40 degrees because I climatized to it.
That's not a dangerous temperature. That's not a dangerous.
What I'm saying,
it's not dangerous.
Let me finish.
No, you're wrong.
I know we're out of time, but the first time
Allie has a story. We're out of time, and you're wrong.
First time I got back to 70-degree weather, 70 degrees, I was pouring sweat through my shirt like it was a severe heat wave. And it was only 70 degrees, and the reason was I had acclimatized to like a 40-degree temperature 24/7. That was
All right.
that's what I'm. Never mind.
Physiologically, like I just said, physiologically, your body can only handle so much. You can acclimatize to, you can acclimatize to hot temperatures. You can acclimatize to cold temperatures. Yes, we adapt. We are adaptable beings. But there is a limit to that adaptation. There is a limit to our cellular, physiological, metabolic ability to survive in really super hot, wet temperatures. So, yeah. Allie, let's talk about pain in mice. Do I look like a pained mouse right now?
Maybe. I'm not sure. I'd have to look at the mouse grimace scale, which has been invented by a couple of professors. Basically, they found out that mice show discomfort like through pain by facial expressions, just in the same way that humans do. So they kind of squinch up their face when they're experiencing pain, just like humans do. And they used this and they studied this. They looked at 5 different facial features, including orbital tightening, which is just eye closing, nose and cheek bulges, and ear and whisker positions, according to the severity of the stimulus they were giving them. They were injecting mild inflammatories, basically, to give them little different kinds of pain. And from this, they developed a scale that measured the different expressions at the different levels of pain. And one of the top researchers on the study said, the mouse grimace scale provides a measurement system that will both accelerate the development of new analgesics for humans, but also analgesics for humans, but also eliminate unnecessary suffering of laboratory mice in biomedical research. There are also serious implications for the improvement of veterinary care more generally. So yeah, they've got an actual scale that they can use, not just for mice. They can use it for other animals as well.
I think it's good that they're able to find a recognizable feature. I mean, the idea of pain in animals has been ignored and gone unstudied for so long that, it's too bad they had to hurt some mice to see what it looks like to be in pain, but hopefully it'll help in the long run.
Definitely, and that's something that's really difficult in veterinary stuff in general because, the animals can't tell them what kind of pain they're in. But they actually developed this scale from using human models. It was one of the professors, Kenneth Craig. He works specifically in facial expressions in human infants and other people with verbal communication limitations. So he was the one who developed it from the different facial features on the mice. So it was actually from humans to mice, which is interesting. And you can Google it and you can actually see the scale and with the different pictures of the different mouse expressions.
I think there's something to be said. I was trying to think of what happens when I stub my toe or when, cut my finger or something. How do I squint my face up? Like, what happens?
Yeah, well, I don't think the mice
Nose bulge.
I don't think the mice are dropping the F-bomb.
Yeah, probably not.
Yeah, you can measure human pain by the loudness of the cursing that comes right after. Hey, I think we've reached the end.
We are out of time. I'd love to tell everybody, if you haven't started reading already, there is still time to read along with the TWiS Book Club. This month's book of the month is Beyond Human, Living with Robots and Cyborgs. Yeah, you can get involved in conversations about the book at twisbookclub.ning.com. And I'd love to shout out to Ian George, Dan Mumford, JD Townsend, Beth Gilmer, and Christopher Abel and Ed Dyer. As always, thank you for the stories. Thank you for your letters. Hopefully next week we'll get to some listener mailbag.
Thank you, everyone, for listening. We hope you enjoyed the show. TWiS is available via podcast on the iTunes. You can look us up there. Google us on the iTunes, or you can visit our site, www.twis.org. Click on the subscribe button, and it will guide you through to the podcast.
And for any more information on anything you've heard here today, show notes are going to be available on our website at some point in the future, because we're actually in the middle of redesigning the website and we've lost our Blogger FTP upableness. And so I'm transitioning from Blogger to WordPress and we're having some issues. But soon in the future, you will be able to go to www.TWIS.org and get show notes with links, because Allie is going to help and write them. It's nice.
If there's somebody you'd like us to talk to, a story you'd like us to cover, you can send us the links or the info at Justin at thisweekinscience.com or Kirsten at thisweekinscience.com. We want to hear from you, get your feedback. Be sure to put TWIS somewhere in the subject, or you will be spam filtered into oblivion.
Oblivion, that's right.
Oblivion.
And you can find us on the Twitter as well. I'm at Dr. Kiki. Justin is at Jacksonfly. And
We're also on Facebook. Kirsten's got a fan page, so you can be her fan, kept at that arm's length distance. Or you can just be my friend, because I don't have fans.
That's right. And Allie, do you have a Twitter if anyone wants to find you on Twitter?
Yeah, it's at Allie_Bob.
Allie Bob.
What's an underslash?
Is that right? Underdash? I don't know.
Underscore,
line
under
that's on the
dash.
bottom.
That's right. It's under there. And we'll be back here next week. And we hope that you will join us again for more great science news.
And if you've learned anything from today's show, remember,
it's all in your head. Thanks for watching, everyone.
So my favorite confounding correlation is autism and the vaccines. As more and more people got vaccines, the autism rate kept going up. So this was the correlation. This is where autism was coming from. It must be from the vaccines because they're both increasing. And then they took the mercury out of the vaccines, and at the time the correlation was the autism rates actually increased. They spiked. So the confounding correlation there then is that mercury in vaccines helps reduce the amount of autism cases. And so we should be putting lots of mercury in our vaccines.
That's right. Load it up with more and more mercury. It's just, yeah.
So here's a story we didn't get to. This is something amazing that I didn't know would be possible. This is out of University of California, San Diego School of Medicine. Researchers say that they've discovered a common intestinal bacteria that appears to promote tumor growth and genetically susceptible mice. So basically, giving cancer to mice, when they knocked out this normally beneficial bacteria, they found that it was the FAP, or familial adenomatous polypsis, inherited condition, which creates initially a bunch of benign polyps in the large intestines, eventually turning into malignant colon cancer. If they knocked out this beneficial bacteria, no cancer. What kind of an odd relationship is that?
Yeah.
You know, that's like a whole, I mean, I guess we know that cancers can be virus related. Is it the what's the one that you're supposed to get your daughters and sons inoculated from when they're young, so that the
HPV. Is that the one
HPV, right. The HPV virus can
cause cervical cancer.
Right. So now here's a beneficial bacteria that seems to be aiding and abetting an intestinal cancer and colon cancer. We have much to learn, people. We don't know what we're dealing with yet. The world is very strange. So even though it's genetically inheritable, you have something that is, I guess, an environmental susceptibility is now what we're going to have to start thinking perhaps of some of these genetically inherited diseases as. It's not so much like genetically it's on your list, so you're going to come down with it, but and possibly that it's just an environmental susceptibility, so that if you overcome that thing in the environment that would normally trigger that genetically inherited weakness, you can then overcome and prevent or avoid your disease. Very interesting, though.
Yeah. I love that there's so much that we do need to learn still about what triggers cancer, autoimmune diseases, all these, there's so much that's reliant on the environment and being in the wrong place and at the wrong time. Did you breathe in some, microbial spores or, did something happen to trigger you? Was it an allergy? Was it something you ate? Was it something that just existed in your environment for a while? There's so many things that we don't know. Like we were talking last week about multiple sclerosis, and that's one that they have no idea. It's like, oh, we thought it was genes and we know it's a little bit of of environment and stuff, but now we're really confused. We don't know anything. Back to the
and that's the thing. I mean, we have discovered that there are genetic markers for disease that give you a higher potential. But now that we know that there's the actual triggers for these things are environmental, that does mess everything up. Because then it means we don't have the blueprint. It means DNA, far from being the troubleshooting guide that we really hoped it would be, is not. It's the manual that asks you to refer to another manual which you haven't purchased yet. You have to go back to the bookstore and figure out where this like every page of the genetic code is starting to do that to us. It's more of a what do you call it, like a bibliography or something.
Yeah. Maddie in the chat room is saying treatments are just as bad. They don't know why they work, but they use them because it's testable. That's true. There's some that they do know exactly how it works, but there are some treatments that it works, and they honestly have an inkling of the pathways that they act on and what ends up happening. But there are some diseases they have no idea what the treatment actually does. It just helps. So there's, even in terms of the medicine that we're giving people, there's a lot more to do. You're so right. I don't know. People in the chat room have had a whole bunch of comments. You guys got good comments out there.
What are they saying?
Oh yeah. Is that you? No, that's not you, Justin.
Yeah? No.
Somebody's saying they don't like anything that's administered with a needle. Well, I don't know. Maybe they'll get past it. You can just have like a Flonase like sniffer. You don't have to have a needle full of vaccine. You can just inhale your vaccine. It would be good.
How can you be anti-clothes? Like, what do you wear? Like unstitched clothing?
Velcro.
You wrap yourself in Velcro and saran wrap? Like, what do you do?
I don't know.
Did we lose Allie? Did Allie have to go?
No,
there she is.
She's hanging out. She's hanging out. Yeah. Hey, Allie, are you working on your big epigenetics?
Yeah, I'm working on an epigenetics story, or like the last 10 years or so. I'm trying to get that in. I'm very busy though, so it's going pretty slowly.
Yeah. How's the school schedule with the added?
Yeah,
project?
It's pretty heavy actually, but I'm working on it.
Cool. Yeah, that'll be the third. You've done 2 already. This will be your third of your decade of science, decade of TWiS reviews. So I'm excited. Epigenetics is turning into something really big and interesting. So
yeah,
I'm excited. Someday soon. This is a good tease. We can just tell people someday soon. at a video broadcast near you. Let's see. What are people when looking at fossils in general? How do they know it's not just an outlier? Or how do they know it's not just a genetic abnormality? That's a good question. They
assume it isn't.
Yeah. Well, this is the whole thing with Homo floresiensis. Where they went back and forth for years. They said, oh, it's a new species of human. It's the little tiny people, the hobbit.
Oh, it's microphagia. It's just some diseased dwarf or a dozen of them with smaller
big-headed
tools.
Yeah, what was it? A big-headed. They had a big head. So it was like big-headed and short-limbed or something. And so they're like, oh, it's a dwarf. And then they decided that it wasn't.
Well, I decided before they did, though. That's another one. That's another one I got. I've been on a roll on this show. I've been calling them early. Real early.
Good.
I even called the Super Bowl this year. I got to keep with. I should change this. We should do a different show. We should have people call in, ask me questions, and me predict things about their lives. But then like a psychic hotline instead.
You've said this before.
I think I'm way ahead. I think I'm way ahead of the time frame that are going on.
Oh my God. It's hilarious. Well, it looks as though John has got the files transferring, moving to the Pogo plug so that I can get a hold of the files and edit them down. Why is my nose?
Let's down be in the forum says, I don't know if Justin even has a BS, but he reads up a lot.
He has a lot of BS. I had to do
I have a BS in opinionology. That's my profession. That's my professional street cred right there is opinionology. And after a while of having many, many opinions, you have to at some point start to defend them. And it makes you go and read books. And sometimes you have to change your opinions because it's, because you've read stuff that changed your opinion. But it's about being really bookish and spending all of your time curled up with a good book instead of a nice woman. Which I don't regret doing because I know lots of things about stuff now. And so, like, I don't feel like I've been lonely my whole life. I feel like I've been learning my whole life, which is really, it's better. It's more important to have learned than to have loved and not learned because I think...
It's better to have learned than never to have loved at all. Oh, wait, what? Yeah. Opinionologists wear toupees. Thanks, Dave.
It looks real, doesn't it? Or is it too...
It does.
I think it looks real. It looks like a real toupee. Anyway.
You're doing good with the toupee-like hairdo this evening. It's pretty I like it. You have a new painting behind you. Do you know what?
Yes, I've counted. I think I'm up to 40 paintings in the house.
Wow.
Yeah, it's starting to take over.
It has taken over. Rotate through them weekly.
Yeah. Yeah, I think I'll try. Yeah, I could put a different one up there every week. This is not staying here. There's another one that's going to stay here eventually. I just have to find it.
It's gone somewhere else. Yeah. Cool. Oh,
so anybody watch Larry King? They had Showstack, Bren. They were talking about Hawking.
Oh yeah, no, I missed it.
And they had Dan Aykroyd on there for some reason, and Michio Kaku.
That Michio Kaku makes sense. Dan Aykroyd, not so.
Michio Kaku makes no sense. I'm sorry. Michio Kaku needs to take a lesson in evolution, or lesson in evolution, because I think he's allowing or maybe just doesn't care. Is allowing people to assume that there are people out there looking back at us. I don't know. I have issues with Kaku's version. He's a physicist, great. He's a very smart cat, great. I think he needs some more life sciences. Showstack, I like him, but I don't know. I think he needs to give up on sending radio signals out there, and really, if he wants to make contact he needs to embrace robots. He really needs to embrace the idea.
He's big on the robots. I mean, SETI is just, that's one project.
This is his day gig. Okay.
Yeah, it's his day gig. He likes the robots. He's not against the robots. That's for sure.
I think just in case, because we have somewhat of a new audience, just in case anybody hasn't heard my take on the Greys yet. You've heard this too many times, haven't you, Kirsten?
I think so.
Okay, but we have audience members who maybe haven't. So if you just assume every report about aliens on planet Earth is true, just take it at face value and say there's these little gray men, occasionally abduct people, and then they probe them with in the no spot. The only way this makes sense evolutionarily, because they have 2 arms, 2 legs. They have a head, the eyes, mouth, nose. Everything is proportionally in the same place as it would be in a human. The chances of that evolutionarily developing into a sentient race on another planet would be impossible. Just it would never happen. So the only explanation is they're from the future, right? That's why they would need the spaceship, because if you time travel, like here's the Earth, right? If you time traveled back in time 24 hours, Allie, where would you be?
Class?
No. You would if you travel back in time, just in time, 24 hours, you would be in the middle of dark, cold space.
Okay.
And have no way, because the sun, the solar system's spinning, the Earth is spinning around the Earth, around itself, or around the sun, around itself. The sun is moving, the solar system's moving, the galaxies. You'd be like hundreds and hundreds of thousands of miles away in a mere 24 hours. So you went back in time, 24 hours, poof, you're out in the middle of space, and you're dead. So the only way to time travel and visit the Earth is to time travel in a spaceship. Fly yourself back to the Earth. So then the question is, well, why, if these future humans are here, why are they abducting people and anally probing them? The only answer that would make sense in that scenario is they're missing some of the microflora. Antibacterial soaps have been overused. They're missing some of their really crucial microflora in the gut. And so they're taking samples of microflora to bring back to the future so that proper digestion, can happen again.
Ha ha. Web5899 says you sound just like Michio Kaku. That's hilarious.
Am I doing a Michio Kaku? Well, that's it. But I'm not saying I believe it. I'm not saying I believe this. But if you take, that would be the only scenario that would make sense. Because whatever life is out there that is extrasolar, is outside of off our planet even, doesn't even have to be out of the solar system. Any other life that's anywhere in the universe is not going to look anything like us. May not have communication in the way we have communication. May not, Michio Kaku's assumption is that, or I guess the talking assumption that any life will have legs and eyes and these sorts of things. There's no formula that says that that's going to be necessary on some other planet. There's going to be completely different concept and completely different technology.
It's possible. I mean, it's possible they will look like us. We have no idea. I mean, it's possible that only planets that have Earth-like gravity and water and electromagnetic radiation that develop makes us end up having eyes that detect that light wave, those light waves, and ears that hear the sound waves. It's very possible that the physics works exactly the same, and so they're going to look just like us. Very possible.
The physics might be the same.
Very possible.
If the psychology would also have to be the same for the technologies to be similar. Because our whole way of conceiving the world, the way we've developed physics, the way it is up to this point.
What do you mean the psychology? We don't have anal probes yet. Do we have anal probes? Or are you talking about like enemas or something? What's going on here?
That has nothing to do with the anus, what I was saying. Nothing whatsoever. Not even, no. I meant the physics, the technology might be completely different. Because all of our technology and all of our physics, the way we conceive the universe around us, the way we conceive travel or technology or anything, is based on our psychology as how we came into being on the planet. If you were on a different planet that maybe wasn't a predator-prey planet, had a different level of gravity, had different concepts about the way the universe worked, their approach to physics might be different. So I wonder what that technology would be, because there could be gigantic technology gaps, right? They could have space travel. They'd have to have gotten here. So we assume that a lot of stuff is figured out, but there could be huge gaps. Like perhaps, there's society that never discovered fire. Like that could be something completely foreign or non-existent wherever they're from. So that could be a really fascinating thing to see, the fact that Earthlings can control and use fire and cook with it even. Maybe they've never cooked food before. So it's a technology gap. We've sort of had that here on Earth in television, right? So the first televisions exist, and the next step is we're broadcasting television through the electromagnetic spectrum, and we're picking it up on antennas everywhere. And then we put a satellite in space, and we start beaming television down to people from satellites. And then decades and decades later, we figure out a technology that allows us to run a cable from one sending unit to each television so that it can get the feed. That last step, that cable television, seems like it should have been the first step. Like the first step would have been to run it down a cable to a receiver, and that would have been the basis of the technology. And then figuring out how to do broadcast would have come later. And then figuring out, we can go into space and send it down the satellite. But in fact, we sort of skipped the basic technology there, and only because it makes sense for other reasons do we go back to it. So there could be a lot of the most fascinating.
As a result, the aliens are going to think that we all died because our television broadcasts are going to be, are dying out. Our radio broadcasts are dying out. Everything's going cable. Everything's going internal to the planet. So there's going to go. It's all those broadcasts are going way out to space. They're all going. It's just going to silence. Sudden silence.
Television will all decay before it gets picked up in any meaningful way. The radar is pretty good though. Our military radar is probably going to penetrate the furthest. Whether or not it'll be decipherable from any other sort of naturally occurring radars out there is kind of uncertain. But
how many whales in space is it going to kill? I just want to know. I have to go eat dinner.
The first contact we're likely to have is going to be our robot passing another robot in the middle of the night, and hopefully the technologies aren't so divergent that the two robots seeking intelligent life in space don't just pass each other by on sort of different wavelengths and frequencies and miss each other altogether.
Bleep, bloop, bloop, bleep. No.
Strange bots in the night.
Exchanging messages. What? Exchanging bleep, bloop, 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 bleep. And that is it. We're going to say goodnight now, folks. I'm going to say goodnight.